Alright, we're going to solve a system of linear equations in three variables here. Our goal is to create a system of linear equations in two variables using these three equations with three variables. So that's what our goal is. So what I'm going to do is I'm going to write here what our goal is. Our goal is to create a system of linear equations in two variables. Alright, so in order to do this, first thing we have to do is we have to decide which variable we want to eliminate in order to create two equations with two unknowns. So looking at the three equations with three unknowns, let's look at the x's, let's look at the y's, and let's look at the z's, and let's decide which variable we want to eliminate. And I'm looking at the coefficients of these variables to determine which one has the easiest least common multiple to come up with. And I'm also looking at the signs to make that easier on me because I do want to eliminate. So looking at these, if I look at the x's, this is what I have for the coefficients. I have a 3, a 1, and a 2. The least common multiple of these three coefficients would be 6. Looking at the y's, they all have negative signs, and their least common multiple is a 6 as well. And looking at the z's, I've got some positives and I got a negative term, and their least common multiple is 4. So I'm going to go with the z's. Z's are my winner. Yay! Just because the LCM is a little bit easier to come up with because it's a 4. I like to work with smaller numbers when I'm trying to cancel things out. And I also like the fact that I've got a combination there of some positives and also a negative. So I always like to, when I don't have to multiply by a negative to cancel something out, I like to take advantage of that. I like to keep that. So, but I think ultimately the first thing I look at is the smallest LCM. That's the 4. Alright, so let's go ahead and cancel out the z's. So I'm going to have to make sure I remember this. I'm canceling out the z's, and I'm going to end up with a system of linear equations in two variables, and those two variables that I'm going to be left over with are going to be the x's and the y's. So this is what I'm going to have left over. I'm going to have x and y left over in the two equations I'm going to create. Okay, so that's kind of our big goal. We want to keep that in mind. Okay. Alright, to start off here, what I'm going to do is I'm going to label these equations so that way I can keep referring back to them. I'm going to label these as equation 1, 2, and 3. Let me get rid of the highlighting that I did here. Let's call the first equation equation 1, then equation 2, equation 3, and that way I can refer to them. So that way you know which ones I'm working with. I'm going to start off by working with equation 1 and 2. I want to cancel out the z terms. I've got a positive 4z and a positive 2z. So the way to cancel those 2z terms out is I'm going to have to multiply the equation number 2 by a negative 2. So let me go ahead and write that in here. I'm going to set a parentheses here, and I'm going to make sure I multiply every term in the equation by a negative 2. Multiply, 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 multiply. Equation 1 is going to stay exactly the same, so I will end up with 3x minus 3y plus 4z is equal to negative 1. Equation 2 will turn into negative 2x plus, oh, I gotta remember I'm multiplying, don't forget, plus 4y minus 4z is equal to negative 4. And you want to double check this, because if you forgot to multiply one of these terms by a negative, or you didn't multiply something correctly, it's going to make your life very hard and you're not going to be able to solve this system. So just quickly go back and double check and make sure that everything was multiplied correctly. All right, now that we did everything here correctly, we're ready to add these two equations together. The z terms will cancel out, and that's good because that's what we wanted. We'll be left with x plus y is equal to negative 5. I'm going to refer to this equation as equation number 5. No, I meant number 4. I'm sorry. I don't have a number 4. So that way when I'm using this equation and I'm referring to it, you know I'll refer to it as equation number 4. Okay, we need another equation with two unknowns. So now I have to use the equation that I didn't use last time. I have to use equation number 3. So in this step, I think it's very important that you remember you have to use the equation you have not used. Okay, you can't use the same 2 that you just used. So I definitely have to use number 3. So I'm just going to make a note of that here. I have to use equation 3. Okay, so let's write down. I'm going to choose to use equation 2 and equation 3. Okay, I could have used equation 1 and 3. It was my choice. But I decided to use number 2 just because if I look at the LCM of 2 and 3, it's even easier to work with. It's just a 2. So I'm going to have x minus 2y plus 2z is equal to 2. And 2x minus 2y minus z is equal to 3. I'm going to multiply equation number 3 with a number 2, so that way my z terms will cancel out. So I'm looking at the z terms here. Remember, I have to cancel out the z's. I'm not allowed to cancel out anything else because we said we were going to cancel out the z's so we can create our equation in x and y. And equation number 3 is missing a 2 in order for me to be able to cancel that out. So I'm going to multiply equation number 3 by positive 2. Okay, so we're going to have our equation number 2 stays exactly the same. So we're going to have x minus 2y plus 2z is equal to 2. Equation number 3 will turn into 4x minus 4y minus 2z is equal to 6. Now we add those two together and our z terms cancel out, which is exactly what we wanted. And we are going to be left with 5x minus 6y is equal to 8. And I'm going to call this equation number 5. So if you're looking at our two equations that we have here, equation number 4 and equation number 5, what we have achieved, we have created a system of linear equations in 2 variables, and we already know how to solve these systems. We can use this method of substitution, or we can use the method of elimination. Okay, so now I'm going to write here, we are going to use equations 4 and 5. Okay, and you can choose to use substitution or elimination. You can use substitution or elimination method. Okay, it's your choice. I'm going to choose to use elimination. So let me write down these equations. Number 4 is x plus y is equal to negative 5. Number 5 is 5x minus 6y is equal to 8. I'm going to choose to cancel out the y's. I know it's not the smallest LCM. I know the LCM of x's is 5, but the y's, the signs are opposites, and I don't have to worry about multiplying through by a negative. And if you already know that you're prone to making mistakes when you multiply through by a negative, then you should keep that in mind when you are working out these problems. So this is going to give me 6x plus 6y is equal to negative 30. And the second equation is going to stay exactly the same. We didn't have to multiply it by anything. Add these two equations together and our y terms will cancel out. That's exactly what we wanted to happen. And we're left with 11x is equal to negative 22. So x is equal to negative 2. Now that you've found the value to x, we still need to find the value to y and z. Before we find the one to z, we're going to first find the one to x. And we're going to use either equation 4 or 5 to find the value for y. So I'm going to write that down. Now we are going to use equation 4 or 5, either one. You don't use both, just choose one. And substitute x equal to negative 2 and solve for y. I'm going to use equation number 4. Equation number 4 is easier to work with, I think, because if you look at the coefficients of the x and y, we have coefficients of 1, and I'd rather work with that equation. So instead of x here, I'm going to substitute x with x equal to negative 2. So this will be negative 2 plus y is equal to negative 5. Solve for y. So I'm going to add 2 to both sides. This will give me y is equal to negative 3. We are almost done. We now need z. To get z, you have to use equations 1, 2, or 3. Not all three of them, just choose one. So use equation 1, 2, or 3. And substitute x equal to negative 2, y equal to negative 3, and solve for z. It really doesn't matter which one you choose, so I'm just going to randomly choose one. I'm going to choose to work with equation number 2. So if you recall, equation number 2 was x minus 2y plus 2z is equal to 2. I'm going to substitute. Instead of x, I'm going to put negative 2. Instead of y, I'm going to choose to substitute negative 3. So let me go ahead and substitute there. Negative 2 here, and negative 3 for y. And now I'm ready to solve for z. All right, negative 2 plus 6 plus 2z is equal to 2. Combine like terms. Negative 2 plus 6 is going to give me 4. And 4 plus 2z is equal to 2. I'm going to subtract 4 from both sides. So that's going to give me 2z is equal to negative 2. Divide both sides by 2, and voila, we get z is equal to negative 1. So now what you want to do is you want to write your answer as an ordered triple. Write solution as an ordered triple, right? X goes first, Y goes second, Z goes last. Just think about the alphabet, X, Y, Z. So our X value was negative 2, comma, Y was negative 3, Z is negative 1. So this represents a point in three-dimensional space. That's why we have 3 values. And it's basically where these 3 equations, each one of these equations represents a plane in three-dimensional space. And it's where these 3 planes intersect. They intersect at this ordered triple. All right? So that's it. In order to check your work, you would want to substitute the ordered triple back into all 3 original equations, equations 1, 2, and 3, and it has to come out true for all 3. If it doesn't come out true for all 3, that means we made a mistake. So I'll leave that check for you. All right, that's it for this problem. Bye. Hi. We're going to solve a system of linear equations in 3 variables. And this system's a little bit different from the last one we solved because if you notice, it has some missing spots right here. Those missing spots, it's like it's missing some of the variables there, and they just left the space so that you'd have it's almost like a placeholder, so you can see where the variable was supposed to go, but there's no variable there. But this system would mean the exact same thing, if I had written it, just like this: 2x minus 4z is equal to negative 7, x plus 6y is equal to 5, and 2y minus z is equal to 2. So, this and this, they mean exactly the same thing. So I don't want you to think like they're different. They're not. Okay? The spaces there, it's just supposed to make it easier for you so that when you see the problem, oh, there was supposed to be another term there, but there isn't one. If you want, you could, I guess, write in a 0, like a 0y term. If you really wanted to, you could put like a 0y, just so you could be like, oh, I know it was supposed to have a term there, but it doesn't have one there. Okay, so now that we talked about that, let's go back and erase these spots here. Just going to erase that. Alright, so this one turns out, I think, to be a little bit easier than the other one because it's actually got, less work. We can actually reach our goal of having our 2 equations with 2 unknowns a little bit faster than we did with the last problem that I solved. So what I'm going to do here is I'm going to choose to eliminate these x's. And once I choose to eliminate those x's, all I'm going to be left over with is I'm going to have a y term and a z term. And that's going to set us up perfectly for having a y term and a z term, just like this equation right here. This one has a y and a z, and if I could create an equation with a y and a z in it, I'd be able to start solving my system of linear equations in 2 variables even faster. So that's my goal. That's what I'm going to do. Okay? All right, let's go ahead and label these equations so that I can get my 2 equations with 2 unknowns now. I'm going to label this as equation number 1, equation number 2, equation number 3. And I'm going to choose to eliminate the x's in equation number 1 and equation number 2. In order to do that, I need to multiply equation number 2 by a negative 2. So I'm going to distribute, distribute, distribute. Oops, what's that over there? Let's erase that. Equation number 1 is going to stay exactly the same. Equation number 2 is going to turn into negative 2x minus 12y is equal to negative 10. Add those two equations together, so my x's will cancel out, and I'll be left with negative 12y minus 4z is equal to negative 17. Let's call this equation number 4. And now if we compare equation number 4 to our equation number 3, notice that we have y and z and y and z. So we have an equation with y and z and an equation over here with y and z. So I have achieved my goal of creating my two equations with my two unknowns even faster than I did with the last problem I solved. That's good. That's good news. All right, so let's go ahead and rewrite this. I'm going to rewrite this using equation 3 and 4 now. 3 and 4. Equation 3 was 2y minus z is equal to 2. Equation number 4 was negative 12y minus 4z is equal to negative 17. All right. All right, so now we're ready to solve our system. So we're going to solve the system of linear equations with two variables. And you can choose to use substitution or the elimination method. I'm going to use elimination. Okay, and I'm going to choose to eliminate the y's because I noticed that I have a negative and a positive, and that way I don't have to multiply one of my equations by negative. Whereas if I choose to eliminate the z's, I'm going to have to multiply one by a negative. And if you already know you're prone to, forgetting to multiply a term by a negative, you should try to find which is the easiest way for you to do this, or the best way, so that you're not as likely to make a mistake. I'm going to, no, I don't have to multiply by a negative. I need to multiply by a positive 6. Positive 6. Distribute. Distribute. Oops. Distribute. So my equation 3 will turn into 12y minus 6z is equal to 12. My equation number 4 stays exactly the same. I don't have to multiply it by anything. And now I can cancel out my y terms, and I'm left with negative 10z is equal to negative 5. Now I can divide both sides by a negative 10. And z will be, negative 10. Forgot my negative there. See, I told you, gotta be careful with those negatives. I warned you. Z is equal to positive 1/2. After you reduce a negative 5/10, it reduces to 1/2. Now we're ready to go back and find y. You're going to use equation 3 or 4 to find y. So let's say here, use equation 3 or 4 to solve for y. Okay. So either one is going to get you what you want. I'm going to use equation number 3. It just looks a little bit easier to work with. It looks like the numbers, the coefficients there on the variables are a little smaller. So let's write down here equation number 3. Copy it down. 2y minus z is equal to 2. And instead of z, I'm going to substitute z equal to 1/2. So good. So 2y minus, let me write this y up a little higher. 2y minus 1/2 is equal to 2. So now we're ready to solve for y. I'm going to add 1/2 to both sides of my equation. I need to find an LCD here. My LCD is going to be 2. So I'm going to end up adding 4/2 plus 1/2. And that's going to give me 5/2. So now we have 2y is equal to 5/2. Now I'm ready to divide both sides by 2. When I divide 5/2 by 2, I am actually going to multiply by the reciprocal. So y is going to be equal to 5/2 times, the reciprocal of the divisor is going to be 1/2. So 5/2 times 1/2 is going to give me 5/4. So I found another value to my ordered triple. Now I need to find x. In order to find x, I'm going to have to go back and use one of the equations with x in it. So I have two choices. I could use equation 1 or I could use equation 2. Because they both have an x, and I know the value to z, and I know the value to y. I'm going to choose to use equation number 1. Alright, let's go ahead and use equation 1. So let me copy it down. Equation number 1 was 2x minus 4z is equal to -7. And I'm going to substitute, instead of z, I'm going to substitute 1/2. Because I'm using the one that has a z in it. So we're going back up here to this 1/2 up here. And substitute again here. Alright, now we're going to have 2x minus 4 times 1/2 is equal to -7. And that'll be 2x minus 4/2 is equal to -7. 4/2 will reduce to -2. I'm going to add 2 to both sides. And we'll be left here with 2x is equal to -5. Divide both sides by 2. And we get x is equal to -5/2. So my ordered triple, remember your ordered triple, you write it in terms of x, y, and z. In order of the alphabet, x, y, z. X goes first. So we're going to write -5/2 first, comma, 5/4, comma, and z was +1/2. And there's our answer. And you can substitute it back into all three of the original equations for equations 1, 2, and 3 to double check it. Make sure it comes out true for all three. And that way you'll feel good about your answer, that you did everything correctly. All right, that's it. Bye.